10.1 is circles, and so let's start and let's draw a picture of a circle on an XY plane, and hopefully I can draw it semi-round. Now we know that this point in the middle is called the center of our circle, and you might remember that the distance from the center to the circle anywhere is called the radius. So we'll write that down. We have to remember that terminology. And then if we're on an XY plane, look what we can do. Let's call our center HK. So we're going to name it, we're going to pretend we're over H up K. And then we know this point changes as it moves around the circle. So we'll just call it XY because it's constantly changing. But here's what you need to know. If I drew an imaginary right triangle right there, I could use Pythagorean's theorem to find the radius. And I would get that by finding the length of this side right here, which would be this x value, subtract this h value, or vice versa, this h value subtract this x value. And I could get the length of this side right here by taking this y value, subtract this y value, which is k. So I get each side, by one side I'll go y subtract k, and that gives me one side, and the other side I'll do x subtract h, that gives me the other side. Now, if I square this side and square this side, it will equal the radius, which is the hypotenuse squared. Right? We know a squared plus b squared equals c squared when it's a right triangle. So I'm going to square that side, and I'm going to square that side, and add them, and they will equal the radius squared. Now, if the circle is on the very center, then my h and my k are 0. So that equation would be simplified. We wouldn't have to subtract something from something. We would just say x squared plus y squared equals the radius squared. So that's if the circle is on the center. And so we want to just make sure we know those two equations. Those are the basis of this section. And they're all important. And the first thing they're going to do is just simply ask you to graph. And for example, they could give you, this is about as simple as it could get. They could graph x squared plus y squared equals 9. Now as soon as you see the x squared and y squared, you know that you have a circle. Or you could have a hyperbola or ellipse, but we'll learn about those in 1050. So for now, because there's no coefficient, because it's a plus, and because both of those are squared, you know you have a circle. If only one of them is squared, you have a parabola. You might remember graphing parabolas earlier. So in this circle, since I don't have an h and k, I know that my center must be at the origin. So my center is 0, 0. And can you figure out what the radius would be? The radius isn't 9, it's whatever is squared there. So it's 3 squared. So the radius is 3. So to graph this, I go to my center first, and then I just need to go 3 in every direction. So 3 up, 3 down, 3 right, 3 left. You could even go 3 diagonal, but it would be harder to stay accurate. And then try to draw your circle as round as you can. My circle, I need a little help drawing those. Let's move up a little bit. Let's try this. Let's say I have x squared plus y plus 2 squared equals 6. Now, do you know the center? Well, the x value doesn't move, so it's still 0. But the y value is shifted. And notice that in your formula that this is subtract. But I'm over here positive h and positive k. So this is actually the opposite sign. If this is a plus 2, we're going to be at negative 2. And so my center is at over 0, back 2. And that again is because your formula is subtract. And I should write right here that the center is positive h and positive k. And notice that whatever one is with x is your x value. Whatever number is with y is your y value. So this is with the y, and it's the opposite sign. So it's my y value, and it's negative 2. And this one's a little bit trickier, because the radius isn't a perfect square. So I'm just going to write that it's the square root of 6. And we know that the square root of 4 is 2, the square root of 9 is 3, so it's somewhere between 2 and 3. So if I were going to graph that, I would go over 0, down 2, and then I would go about 5. I don't know exactly what that is. 2.5. So I'm going to go about 2.5 in every direction. So I'm about right here, up, 1, 2, about right here, down, 1, 2, about right here, right, and right here, left. And so that is the drawing of that circle. And on your final exam, there's always a circle, and you'll have to pick the right graph typically. So that's how you graph circles. Let's try a little bit harder one. Now, they used to always put these on the final exam, but lately they've been easier, but I don't know what they're going to do this semester. So you need to make sure you can do both this or one like these. So here, again, I go, oh, x is squared and y is squared. It's a plus, no coefficients, so it's a circle, but it doesn't look at all like our standard form, does it? And let's label this. This is standard form of a circle. So what I need to do is make that look like this. And so I'm going to put my x's together, and then I'm going to leave a space because I want to complete the square. I want a perfect square. Then I'm going to write my y's, and we did this with parabolas, so it's not totally foreign. And the 6 I'm just going to leave there on the right side. It'll be part of the radius. If there was another number over here, I might take it over here with the 6. Because now what I want to do is complete the square. I want to add something so that I can write this as a perfect square. So we did this with parabolas, and you might remember that whatever number is here, you take half of it. What is the coefficient of x? You take half of it, which is 1, and then you square it. So 1 squared is 1. So I add 1 to both sides. Oops, but I don't put equal, I put plus. My bad. Plus 1. Now I can't just throw a 1 into my equation. That would totally change it. So how do I make that legal? Well, I make it legal. I need to make that look more like this. I make it legal by doing it to the other side as well. And what you might want to do in your notes is just stick that in a box so that you remember that you inserted it into the problem. Now I have to add something here, so we're going to do the same process. Half of 6 is 3, and 3 squared is 9. So I'm going to add 9 to both sides, and I'm going to stick that in, so I'm going to write it in parentheses, and I'm out of space, so I'm going to write that right there, but it should be right here if I had more room. So I have 6 plus 1 plus 9, so I have 16 over here. That's nice. And right here, I'm going to have y plus something or minus something squared. So now I just need to factor my x's and factor my y's. And you completed the square, so you know it's a perfect square. So you might know from your formula, or it might take one step of following like this and going, oh, x minus 1 times x minus 1 is positive 1, and negative 1 plus negative 1 is negative 2. Foil it however you foil best, and you'll see that it's x minus 1 squared. This one, same thing. We're going to FOIL it, and that one's going to be y plus 3 squared. And you might notice that if you complete the square correctly, this number is always half of this, because that's the number you had before you squared it and put right there. So this is now standard form of my circle, and from that I can see that my center is, what's my center, do you know? This is the x coordinate because it's with the x and it's the opposite sign. This is the y coordinate because it's with the y and it's the opposite sign. And my radius is the square root of 16, so 4. So if I had to graph it, I know I would go over 1, down 3, and from that center I go 4 in every direction. So 1, 2, 3, 4. 1, 2, 3, 4. And then I draw my circle. Oh, pretend that's round. Okay. Should we do one more of those? How about this one? X squared plus y squared plus 4x minus 8y equals 16. So, first step, you might remember we want to group the x's together. So just get the x's beside them and leave a blank to complete the square. Then we'll go to our y's, put the y's together, and once again, leave a space to complete the square. Take half of 4, which is 2, and square it, which is 4. That's our magic number that we add to both sides. Take half of 8, which is 4, and 4 squared is 16. So we add 16 to both sides. So now factoring this, I'm going to factor my x's, and they factor to x plus 2 times x plus 2. I'm going to factor my y's, so they factor to y minus 4 squared. And remember, our shortcut is we know that it's half of the middle number. Half of negative 8 is negative 4. And that works because 4 squared is 16. Alright, and over here I have 16 plus 16 plus 4, so 36. So nice and neat for us. My center, I know, is negative 2, positive 4. My radius is 6. The last thing that you could see on your homework is it will say write the equation of a circle. And they give you the center. They say the center is 2, negative 5, and the radius is 7. So all you have to do is plug it into your standard form. And so you would have x subtract the x coordinate, 2 squared, plus y subtract the y coordinate. So y subtract negative 5 is y plus 5 squared, isn't it? Equals the radius squared. So I take my radius and square it, and that's it. That's done. So work hard on 10.1. Know that there will be a question from this on your final exam. So you can do it.